Okay, so for number 2, what you should have gotten is you should have gotten 24.9, 25.
Wait, do you have to do this?
You do have to round it, yes. 20, this, 0.9. You have to have 24.9. Did we not get that? Okay, so when you add them all together, you should have gotten 399, and then you should have divided that by 16. Is that what everybody did? Then you would have gotten this number, and I'm going to cut off these last two, and I'm going to see that 3 doesn't change my 9. So that's why it's 24.9. Okay? So that's how I would round that. Median and mode is 25, and then my range is 38. How do we feel about mean, median, mode, and range? Good? Does anybody have any other questions for me before we move on? Okay, so what we're going to do now is we're going to look at number 5 here. Okay, Trevin has 4 grades in science class so far, 97, 78, 89, and 94. If he has a test coming up, what grade would he need so his overall average is at least 90? So what we're going to do is 4 grades so far. I'm going to add 97 plus 78 plus 89 plus 94. But then I want to know, what is that last grade going to be? Since I don't know what it is right now, I'm going to write an X there. And then I'm going to divide it. So if he has 4 grades, but I'm adding on 1, how many would I divide that by? 5, because there's going to be 5 grades. And what does that have to equal? Or what does that have to be? What does he want to get? He wants to get 90. So what's going to happen is these things have to be greater than or equal to 90. Because he wants to get at least a 90. He might do better than 90, but he has to get at least a 90. Well, now we're going to solve this just like we normally would. I'm going to add up all of my numbers, my like terms. I'm going to get 358 plus x divided by 5 is greater than or equal to 90. I'm going to draw my line because now how would I solve this 2-step equation or inequality? What would be the first thing I have to get rid of because I can't move anything else before I move this? The 5. How do I get rid of a dividing by 5? So I'm going to multiply both sides by 5. So now I have 358 plus x is greater than or equal to 450. And now what am I going to do? I'm going to subtract 358. So what does Trevin have to at least get? He has to get at least a 92 if he wants to get a 90 for his overall grade. So that's how you'd find one if they asked us to figure out they wanted to get this certain grade or they wanted to get this certain amount, what would they have to at least get? Okay. We're going to skip number 6 and we are going to jump down to our outliers. Who remembers what an outlier is? So let me put it in this way. If we were to think about our age, my age compared to you guys would be the outlier. Because you guys are all really close in age. But how old are you guys? So you guys are about 14, 13. I'm 23. So I am an outlier because my age is not close to your guys's. So an outlier is a data value that is much smaller or larger than the others. So when I have an outlier, I need to know what's the best center point, or what is of my central tendencies, which one's the best one to use? Well, it's most useful to use my mean when there are no outliers. So if there aren't any outliers in our data, that's when you want to use and find your mean, because that's going to best describe your data. There's two cases when I'm going to want to use the median. That's when there are outliers. Or the middle of the data contains no big gaps. So what that means is our numbers are pretty close together. And then it's most useful to use the mode when the data has many repeated values. Okay? So this is when we would use these. So what that's going to do, it says determine which measure of center best represents the data. And then we need to justify our answer and our reasoning for that. So the number of wins by a hockey team in the last 8 years. So I have 56, 45, 26, 48, 54, 52, 49, and 38. Which one, mean, median, or mode, would be the best one to represent my data and their center of the data? Why? Good. It'd be the median because there's an outlier, because 26 is an outlier. Okay. What about the number of minutes that that Ariana spent exercising each day for the past week? 35, 38, 32, 40, 45, 42, and 46. That would be the mean. And why would we choose the mean? There's no outliers, and there's not really a ton of space in between our numbers. No outliers, and numbers are pretty close. Okay. Now, the scores on a math quiz: 80, 50, 70, 80, 80, 90, 100, 80, 100, 60, 80, 50, 80, 80, 80, 70, 90, 90, 80, 100. Mode, why? 80 shows up a lot. You heard me say 80 a lot of times. So 80 repeats a lot. Okay, questions on that? Okay, then we're going to jump ahead. And we're just going to touch on the mean absolute deviation because this does show up a lot in standardized tests. A lot of you had it on your NWEA. It's going to show up a lot from here on out. So I just wanted to touch on this. So what is a mean absolute deviation? Well, this is a measure that gives the average distance each data value, just the average distance of each data value from the mean. So here's what we're going to do. We have 3 steps that we need to follow. Our first step is we have to find the mean. So we have to find the mean. So remember, that's the sum divided by number or total numbers. Then we have to find the distance of each value from the mean. And then step 3 is average or find the mean of those distances. Okay. So they give me 3 sets of data here. We're going to find the mean absolute deviation of set A, B, and C, and we're going to round to the nearest tenth if necessary. Instead of saying mean absolute deviation every single time, we just call it the MAD. Okay, so what we're going to do first is we have to find the mean. So the mean of this data, I'm going to take 1 plus 3 plus 5 plus 14 plus 17. That's going to get me 40. I'm going to divide that by 5 because there's 5 numbers. And my mean for this data is going to be 8. So my mean is 8. Now what I'm going to do is I'm going to see how far are these numbers from 8. So how far is 1 from 8? 7. How far is 3 from 8? 5. How far is 5 from 8? How far is 14 from 8? How far is 17 from 8? 9. What I'm going to do now is I'm going to add those numbers together, and that's going to get me 30. Divide that by 5 because there's 5 numbers, and that's going to get me 6. So my MAD is 6. Okay, so that's what we're doing. If we look at set B now, I'm going to take 5 plus 6 plus 8 plus 9 plus 12. I'm going to get 40. Divide 40 by 5 and I'm going to get 8. So my mean here again is 8. How far away is 5 from 8? How far away is 6 from 8? How far away is 8 from 8? 0. 9 and 12. I'm going to add those together to get 10. Divide that by 5, and my MAD is 2. Now here I have 8 plus 8 plus 8 plus 8 plus 8. That gets me 40. 40 divided by 5 is 8. So here again, my mean is 8. Well, I'm going to take, how far away is 8 from 8? 0. So I'm going to be adding 0 plus 0 plus 0 plus 0 plus 0 divided by 5. Remember, it's okay to have 0 on the top, but there's no way you can have 0 on the bottom. So this is okay to do because 0 is on the top. So what's 0 divided by 5? 0. So our MAD this time is going to be 0. Well, what does this mean? What's the point of this? Well, the closer the MAD is to 0, the less variation there is in the data. Thank you. So do you see how our MAD was 0 here and every single number was 8? That's because our data, all of the points were the exact same. If you look at set B, there isn't a really big range there. I take 12 minus 5, and I have 7 numbers that are in between there. But if you look at data set A, I would take 17 minus 1 to get 16. That's a pretty big range of numbers I have there. And that's the biggest MAD I have. So the closer your numbers are, the closer your MAD's going to be to 0. Any questions? Okay.